Good morning all. Now I would like to discuss about series and parallel connection of resistor. Okay, first we will discuss about series connection. Okay, let us consider two resistors R1 and R2. Okay, 1 dash. One is starting end of first resistor, 1 dash is finishing end of first resistor. Similarly 2 dash. 2 is starting end of second resistor, 2 dash is finishing end of second resistor. Okay, finishing end of one resistor is connected to starting end of another resistor, then those two resistors are said to be in series connection. Okay, in series connection current I is same. You need to check these 2 points. Okay, first point will be finishing end of one element is connected to starting end of another element, and in series connection current I is same. See here, there is no path, there is no another path for the current, right? Same current is flowing through the two resistors R1 and R2. Okay, that is about series connection. Next, coming to parallel connection. Okay, let us consider two resistors R1 and R2. Sorry, R2, 1 dash. Starting end of first resistor, finishing end of first resistor. Starting end of second resistor, finishing end of second resistor. Okay, starting end of two resistors are connected to common point, finishing end of two resistors are connected to common point, then those two resistors are said to be in parallel. Okay, in parallel voltage is same, currents are different. For example, here I current is divided into I1, I2. Okay, that means here voltages will be same. Assume V1 is voltage across first resistor, V2 is voltage across second resistor. Okay, then V1 is equals to V2 here. In parallel voltage is same, currents are different. Okay, starting end is connected to common point and finishing end of the two resistors are connected to common point, then those two elements are said to be in parallel. Okay, that is about series and parallel connection. Okay, now we will solve one or two problems, then you have a clear idea about equivalent resistance. Calculate equivalent resistance are equivalent between A and B terminals. Okay, here I need to calculate equivalent resistance between A and B terminals. Yes, now see here, by seeing the circuit diagram, here I need to calculate equivalent resistance between A and B terminals. Okay, by seeing the circuit diagram, okay, here 2 ohm and 2 ohm are connected in parallel. Okay, 2 ohm in parallel with 2 ohms. Okay, that is when two resistors are connected in parallel, R equivalent formula will be R1 into R2 by R1 plus R2. That is I will write here 2 into 2 by 2 plus 2, right? I will get 4 by 4, 1 ohm, right? Now these two resistors are replaced by single resistor. Now the equivalent circuit will be 1 ohm will be as it is. These two resistors are replaced by single resistor 3 ohm. One ohm, 3 ohm. Just see here, finishing end of one element is connected to starting end, finishing end of one element is connected to starting end of another element, right? And current is same throughout the circuit. That means here all are connected in series. right? Then the resistance between A and B terminals will be in series connection. Resistances will be added 1 plus 1 plus 3, that is equals to 5 ohms. Okay, that is about calculation of equivalent resistance. Next we will solve another problem. Determine the equivalent resistance between A and B terminals. 3 ohm, 2 ohm, 5 ohm, 3 ohm. Okay, determine equivalent resistance between A and B terminals. Okay, for this type of problems where he is asking RAB, we need to proceed from opposite end. Here in this problem he is asking R equivalent between A and B terminals on my right hand side, right? Then I have to proceed from my left hand side, that means from this point. From this point I need to proceed. Okay, for your clear understanding, I am assuming here total current I is divided into I1, I2, right? Now see here, same current is flowing through the 2 ohm and 3 ohm, right? Here 2 ohm and 3 ohm are connected in series. Finishing end of one element is connected to starting end of another element. Same current is flowing, 2 points are satisfied, right? Then 2 ohm and 3 ohm are connected in series. These two are connected in series. When two resistors are connected in series, 2 ohm plus 3 ohm, that is equals to 5 ohm. Okay, you can remember these formulas. R equivalent is equals to R1 plus R2 plus so on Rn for series connection. For parallel connection, 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus so on plus 1 by Rn. I will derive these equations in upcoming classes. Okay, now see here, this resultant value will be 5, right? Now these two resistors are replaced by single resistor. This is 5 ohm, this is 5, AB 3 ohm, right? Now see here, 5 and 5 are connected in parallel. Why? Because see here, this is I2 current, here it is I1 current, right? Two different currents, and starting point is connected to common point, finishing end also connected to common point, right? Then these two are said to be in parallel. For two resistors are connected in parallel, formula will be R1 into R2 by R1 plus R2. You will get 25 by 10, that is 2.5 ohms. Okay, then this resultant value will be 2.5. 2.5 ohm and 3 ohms, right? Then R resistance between A and B terminals is equals to, these two are connected in series. You will get 2.5 plus 3, that is 5.5 ohm is the answer. Okay, in this way you can solve the problems on equivalent resistance. Okay, next class we will discuss about Kirchhoff's laws. Okay, thank you.